actually?
The breakout's for Wednesday at least. Is it Wednesday? It's Tuesday, isn't it? I'm a day ahead of time. All right, I need to get some sleep. People are going to be coming in, but it seems pretty quiet. This is the Polk County Parkway Resurfacing Project session. In this session, we will discuss FDOT's 3D initiatives for model-based design and construction. We'll discuss the past, present, and future design delivery methods for engineered plans and models, including policies, procedures, and standards for next-generation plans. Specifically, we will discuss an 8-mile resurfacing project where the objective was to lead a 3D model for project delivery, project review, permits, CEI inspection, and AMG milling and paving construction. Design and engineering, $3.4 million. Construction letting. Date, November 2019, $16.4 million. Your presenters today are going to be Mr. Gordon Greene, Vice President of Patel & Greene, and Jason Christopher with FDOT Turnpike. So, Jason, take it away.
Well, thank you everyone for joining us this morning and allowing us to be with you here today. It's a capacity crowd, so we're excited to be here. We have a lot of information to go through, so we're just going to run right through that. And if you have any questions, please raise your hand at the end and we'll do our best to answer. So the project we're here today to discuss is the Turnpike's Polk Parkway Resurfacing Project from map 0 to 8. And in a lot of ways, it's a lot like a lot of the projects we do at Florida's Turnpike. It's an 8-mile long, 4-lane divided limited access toll facility with multiple interchanges, including a system-to-system interchange with I-4. It does include milling and resurfacing and full-depth pavement cracking repairs, as well as cross-slope correction, and roadside safety improvements, which includes miscellaneous barrier, minor drainage, traffic, signing and marking, signals, things of that nature. So when we first set out to do this project, our initial goal was to require the contractor to use automated machine guidance, because we wanted to test to see if we could get better cross-slope correction. Because on all of our jobs, all of our resurfacing jobs, we're having to do a lot of cross-slope correction. So we were wondering if we did it with AMG, would we get a better product? As we were going through that process, we determined if we're going to require the contractor to use AMG, we determined that we had to deliver the roadway component as a signed and sealed document, which means we had to deliver the 3D model and the land XML files as a signed and sealed document. And once you go through the effort of putting the roadway in the 3D model, and made sense to go ahead and do the drainage. So our pilot project kept evolving, as you'll start to see here. So once we decided to deliver the 3D model as the signed and sealed contract document, well, we didn't want to have a 2D set of plans also as a signed and sealed document that could represent conflicting information. So what we did, again, evolving in our pilot project, we decided to take a stab at what FDOT is calling next-gen plans, which consist of large format plans and a reduced 2D plan set for things that are already going to be covered in the signed and sealed model. But the end goal, as for all projects, including this pilot project, is to ensure that everything we did, our job was still maintainable and constructible. Anything that didn't meet that criteria was not allowed into this pilot project. So in terms of this project, we delivered information that was in the contract, signed and sealed or in the contract, but we did still provide some FYI for your information sheets to help reviewers, biddability, and constructability. So in terms of the signed and sealed 3D model information, like I said, it was the roadway and drainage component. We signed and sealed the CAD files, which were done in Bentley's MicroStation, as well as signing and sealing the land XML files that were used for AMG paving. Now, to require the contractor to use the AMG paving as part of this project, we had to modify our standard spec package. And the 3 main ones that we did this was, one, we redefined plans, because the word plans is all throughout our spec package, right? So we just redefined plans to include the 3D model, simple enough. The MSPs for the milling and resurfacing were a lot more cumbersome, but in short, we modified the specifications to require the contractor to use AMG, which is a means and methods spec, which you don't ever do. We'll get into that later, why you need your leadership support to do such a thing. And we also touched on QC, verification, tolerances for elevation and crossover, which Gordon will talk to here soon. Now, there were certain things that didn't quite lend themselves to the 3D model, at least at this time here in Florida. So we did still produce a 2D set of plans, which included our level 1 traffic control, since it's a milling and resurfacing job. There wouldn't have been much to put into the 3D model. Our structures components were the same, signalization was the same as we always do. And then for the signing and marking and the lighting, again, part of the next gen pilot, we decided to combine those and put those on the large format plans. So for the 2D information, we did still provide some for information only for the purposes of our reviewers here at the department, as well as the estimators that are going to be going after this job, and people out in the field who may be doing other work other than the paving that's in the XML files. So we did provide a project layout sheet. We did provide roadway and drainage large format plans, not signed and sealed, just for FYI, as well as cross sections, but it's kind of more like a crutch for our internal reviewers so they could still see what's happening every 100 feet without having to get into the model. And like I mentioned with the signing and marking, we combined those and put them into large format plans. Now we were able to successfully remove several 2D plan sheets from the project. Our summary of pad items, we took them out of the plans and we're going to deliver those as a separate bidding document. Curve and coordinate data sheets, that information is in the model, so we didn't sign and seal that. The roadway and drainage plan sheets, like I said, those are gone, that's in the model. We just have large format FYI plans. And roadway cross sections are no longer in the plan, the same thing with drainage structure sheets. So we reduced this plan set by hundreds of pages and saved hundreds of hours in plans production. So with any project, and especially even pilot projects, they carry risk. So we did several things throughout the life of this project to help us manage our risk such that by the time we get out into the field, while there's likely to be issues, we have done a lot of due diligence up front. So our approach to manage the risk of this project, we did several things. First is obtaining approval from your leadership, both at the state level and at the district level, will be critical, especially if you're going to be dictating means and methods. A lot of the departments around the country have a very standard way of producing plans and engineering one way or the other, and that's what the department staff is used to. But when you have a pilot project such as this, where you're basically throwing a lot of that out or deviating from that a lot, you need approval from your leadership. That way it will quickly open up doors for you and knock down roadblocks for people who are used to doing it a certain way. So that was really instrumental, was getting their approval. The other thing we did is throughout the life of the project, we held several internal meetings with stakeholders within the district and within the department, as well as our consultant partners. Construction, maintenance, design, traffic operations, plan specs and estimates. We brought all these people, our design consultant, we brought all these people together to hear their different issues, because sometimes there's competing interests. And by meeting several times throughout the life of the project, we were able to keep up to speed with one another, so everyone knows what each other was doing, why we're doing what we're doing, and it turned out really successful by doing that. So meet with your internal stakeholders often. But there's also external stakeholders who you want to meet with. And for this purpose of this pilot project, our main external stakeholders were going to be the contractors who will be building off of our AMG files, as well as the CEI that's going to have to be inspecting the project off of the 3D model. So we met with them several times, again, to get their feedback. What can and can you not do in a nighttime lane closure, which is what we have to do in the Turnpike. We do all of our milling resurfacing, at least we try to, using nighttime lane closures. So we had to mill, resurface, verify, and QC, and open up the traffic in about 12-hour period. And that was one of the challenges in writing the specs, but I think we got there by meeting with our industry partners. So the department also does phase reviews for every submittal. And so what we did is, because a lot of our reviewers, they're amazing at reviewing 2D plans. They do that multiple times a day, every day. But having to review a 2D or 3D model is not necessarily something that we were proficient in. So to work around that, at least for the purposes of this pilot project, we had brought in some of our GEC home office support that was proficient in the 3D model, and they basically function as like our Uber driver for the 3D model. Our reviewers would sit down with them and ask them questions, and they would navigate through the model. Maybe as a lessons learned, if you guys want to do your own, I would maybe recommend scoping your consultant to do that review as opposed to using an external source, only because they're the ones that are most familiar with the model, and they'll be able to navigate the quickest, because it's about saving time. But as we move forward with the digital delivery and 3D model delivery, it may be the expectation at some point that the department reviewers do have to maybe become proficient in the 3D realm. We also created a plans data, what we call the plans data crosswalk, so we could clearly document the changes that we're making. So we documented the traditional format that we deliver plans, and then we documented the proposed format, and we provided examples as to, or comments as to what the changes were and maybe a little bit of why. And this allowed reviewers and other people that, the contractors, CEI, to see what has changed in a clear manner. Another thing we did was we created the next gen, we piloted what could be the next gen pilot or large format plans where it was practical. And what this allowed us to do is allowed us to reduce the plans production cost, which allowed us to then use those hours that we were going to use on plans production to develop our model. And until we worked through a lot of the technical issues, because again, it's a pilot project, we didn't have all the answers up front. Now, for utility coordination, that's going to be something you can do in almost every project you have. And because of the design schedule of resurfacing, which in Turnpike we do typically try to do resurfacings in 12 to 14 months, there was no time to really bring the UAOs along for the ride with us, so to speak. So we still had to cut drainage structure sheets for them for their review in order to be in compliance with the Florida's Utility Accommodations Manual. So we were still able to provide our partners with what they needed, our utility partners with what they needed, while still producing the 3D deliverables that we're going to give to the contractor. So we did do some sheets for the stakeholders that are not delivered to the contractor because it's in the model. And lastly, a lot of coordination. You cannot coordinate enough. And we coordinated a lot with our partners in central office. They helped us a lot with the specification. Like I mentioned earlier about requiring the contractor to use AMG, that's a means and method. So they helped us work through that, as well as the next generation plans production, and just overall CAD support and technical support for the 3D model. That was very instrumental to help us succeed. And this right here is just an example of the plans data crosswalk, again showing the traditional, what we traditionally do here, and then the proposed format here and some comments here for the various sheets that are in the Florida Design Manual. So with that, I'm going to turn it over to my partner, Greene, who did the bulk of the heavy lifting on this project. Gordon?
Thank you. So when we were awarded this project, it was supposed to be a regular milling and resurfacing project. But once we found out it was going to be this crazy pilot project with everything's delivering in 3D, we decided we had to get organized. So we got together as a team. We had done lots of 3D modeling, but never delivered it as a contract document, obviously, and never on something quite this size. So we knew from our experience that we wanted to have multiple models and break this thing up. So we got together, we divided the project basically in half, west half and east half, and broke the ramps out to where we had 32 models on the project to keep things moving. We also created shapes once we decided the limits of these models, dropped it into a Google Earth KMZ file, and that came in really handy for those that weren't daily into the model and they wanted to look at station 1040 or whatever, they weren't sure what model that was in. They could pull up Google Earth, you could click on the shape, and it would highlight over in the legend in Google Earth to tell you what model that was in, and then you could go in and check it out. It was very helpful. So some of the advantages, keeps everyone moving. We had a team of up to 6 modelers working at the same time during some of the crunch time. So if someone's hitting a snag on one model trying to figure something out, the rest of the team keeps moving, working on their models. It also reduces the impacts of crashes in a couple ways. One, the files are smaller, so you don't have as many crashes, but you're still going to have crashes. But if you lose your work in a day, the impact is less because it's just a smaller model. Some of the disadvantages, if there were any, was just the diligence that's required to keep everything straight, to maintain consistency among the models. Obviously, any change has to be done, in this case, 32 times over, but worth the effort. We also were able to take advantage of some depth and slope reports that were developed by Burns Group in central office, and we're showing you an example of that here. Some of the advantages, you can review the model outside of CAD. You can really see, because this gives it to you in 10-foot increments, you can see your correction areas. You can come in and out of those. You can see that right here in a tabulated format. And you can so you can see what's being modeled, and you can identify any issues. So what I've done is highlight one issue that I think is a good example of the advantage here. So we had a lot of 2 1/4 inch mill on this project, and as I was flipping through the reports, I saw, well, we got 2.52. I don't remember calling for a 2.52 inch mill. So it was just a fat finger transposition of the 2 and the 5, which is about a 1/4 inch difference. You're probably not going to see that as you're clicking through your sections in the model because it's such a small difference. But that's exactly what they would have milled if we would have sent that surface out to the contractor instead of 2 1/4, and that would have given us some issues. So we were able to identify that by using these reports and make that correction. And since this is a milling and resurfacing job, we want to make sure the miller doesn't daylight. So these reports are a great way to identify, find negative numbers. You see a negative number, your daylighting, you need to address that and deepen your mill. And so these reports are really helpful for that. Any disadvantages were that you have to design your templates to accommodate these reports. They're set up to have certain point names and be designed in a certain way. So if you have a preference for designing your templates another way, you're not going to be able to use these reports. But we plan to use them on our 3D modeling, milling resurfacing projects moving forward. So not a major disadvantage. Like Jason said, we incorporated 3D drainage into this project as well. So we designed everything in geocrack drainage, then converted it to SUDA to bring it into 3D. And you can see some of that there. Some of the issues we ran into were the 3D drainage cells, some didn't meet our standards. So for the Type S gutter inlet, that's what I don't know if you can see it or not, but there's a little bit of a gap around this Type S inlet because it was about 1 inch shy of what it should have been all the way around. And we couldn't edit it. If this was a 2D cell, we could have jumped into the cell file, made the corrections, and been fine, but we weren't able to edit that. So we addressed that by some notes on our summary of drainage structure sheet to remind the contractor that the standards control, not the model in that case, and it shouldn't be an issue. There's lots of nuances to drainage design, like tying proposed pipes into an existing pipe, which this is a 3R job, so we had quite a bit of that. And SUDA doesn't really have a good way to accommodate that. So we had to work around. We used a null node. It looks real goofy in the model. It's like this blue square, which is obviously not realistic, but that's how we made that work. And then had some elevation issues where we would assign an elevation to an inlet and it would just change on us. It would go up, it would go down. And so that definitely gave us some anxiety. So we're relying on some notes there and just had to keep chasing it down. You can see one of those. It was right the one day, you open it up the next day and the thing is sunk 6 inches. So that was kind of fun. We took advantage of 3D clash detection to identify utility conflicts. We didn't have a lot of that on this job, but it was still very helpful. And the process really did work really well. You can see these were our only utility conflicts on the job, so we were able to address those easily. Jason mentioned 2D plans and reducing our effort to reduce labeling, reduce sheets, using these for information only large format plans, which we were successful with these 3 foot by 6 foot plans. I think this job would have had 40 something sheets and we ended up with 5, I believe. And I don't know if you can see it, but here's an example of where we had to add some labeling back in because of the feedback we got from contractors that, hey, I'm gonna send this to Jimmy, my guardrail subcontractor. He's not gonna open up a 3D model. How's he gonna estimate this job? We said, okay, we understand. We're taking baby steps here. So a lot of our guardrail labels were basically traditional, begin and end, stations and offsets. But you can see we closed a median crossover here and there are no labels at all. We have some cross hatching and that's it, because the 3D model shows how we're gonna remove that, how we're gonna grade the ditch out to replace it. And so there are no labels for that. We've got a lot of cross-slope correction on this job. Normally that's going to be controlled by a milling control point. We're going to tell the contractor which edge of the lane to control the mill from for slope or depth. You can see there are no milling control points identified on this detail. Instead, we have a label that says proposed 3D model milled surface. So our control is the 3D model. All we had to do was we did identify the depths so we can make sure that our lifts are aligned. We didn't want to end up with any goofy lifts, so we had to do our job as engineers to make sure that it was constructible. We originally wanted these details and the typical sections to be for information only and have the model have that information. And we put quite a bit of effort into finding a seamless way to do that, but our end conclusion was that the software could not really accommodate a very seamless method for that. We basically were embedding the PDFs of the sheets into the model, which seemed pointless. So we pulled back from that. We made those signed and sealed sheets inside the 2D plan set. That'll be something we want to look to do better in the future. Like mentioned, did XML, sign and seal those. We had 4 sets of XML surfaces that we generated: the existing surface from the survey, our proposed finished surface, the milled surface, and also earthwork surfaces, because we did generate earthwork quantities with the 3D model in this job. We were surprised that when we were generating our XMLs from our DGN, they weren't transitioning in a sort of what you see is what you get fashion. It took a little bit of work because there's a lot of horizontal curvature on this job. There's lots of triangle cleanup as it would connect dots. That's not that big a deal, deleting triangles. The bigger surprise was the triangulation along the modeled surface not matching. So we were very diligent as part of our QC process. We would take the XML surface that we generated, we would run it right back through the model and compare it. I don't know if you quite can see here, but this is from our actual QC process. You can see Trevor's red circle there, where there's a brown line here that cuts from the center lane line to somewhere over here on the edge that does not match the mill surface that we modeled. So we have our 3D model, and then we have this XML surface that doesn't match. So it was point names not matching, it was putting stuff 0.01 feet over from where it was, that sort of thing. We had to learn that along the way, but that was definitely something we learned that we didn't expect on this project. Delivering the thing in 3D. Nobody has done that yet, at least in Florida, so to figure out how to sign and seal DGNs and XMLs. So signing and sealing the DGNs was fun. Some of the early conversations were revolved around, we got to put my seal somewhere in this DGN and then maybe identify the coordinates and put that on a sheet. But luckily, the Florida Board of Professional Engineers does not actually require a seal as long as you have the appropriate language that they want to see when you don't have a seal. So that took that away. But when we started to use the Bentley Digital Signatures tool, it took a little bit of working. So the Florida Board wants this paragraph to go along with any sort of digital signature. And this is the dialog where you add your file signature using the Bentley tool. And they give you 3 fields that are all character limited. And so I can't fit that whole paragraph in one of these. Even if I did, they'd be in some field that doesn't really make sense. But luckily, we could break this paragraph up into 3 parts, and it just fit in, except for the last period that you need, but we let that slide. But I've got it in there in a signer field, a location field, and a purpose field. Not ideal, but we made it work. Finicky verifications, I would go in, I would sign and seal a file, I'd make it read-only, I'd come back in, and I'd lose a verification. So I had to chase that a little bit before we delivered the job, but I checked it the other day, they were still all verified, so we're good. And then no batch sign and seal, which is not the end of the world, but it, kind of annoying. On the other hand, the XMLs was a piece of cake. So the DOT, again, Burns Group Central Office developed an XML signer. I can do batch sign and seal. I can select 100 XML files if I want to. It runs right through them, and I can put my whole qualifying statement all together. It's there on a right click. You can call it up. It's awesome. We mentioned modified special provisions that we developed that require the use of automated machine guidance for milling and paving. We did maintain cross-slope control, which is in the standard specs as of now, and you can see the tolerances there. What we added was elevation control, which is a big change, and you can see the tolerances that we included here, which are pretty commensurate with the cross-slope. So with this modified special provision, the contractor is not only going to be required to match the cross-slope that's from our model, but he's also going to be required to build it to the same elevation as our model on the mill surface and also on the finished surface. So that's a big change. And we're also requiring the use of a direct read survey rover to actually perform the quality control on the surface and the verification, as opposed to just a level. Jason?
All right, so as we wrap up this presentation today, I just want to go over some considerations for your agency that you might want to consider as you all go move forward with your potential pilot projects. One of the first things you're going to want to do is identify and define what your objectives are up front before you even pick a project. What is it that your agency wants to achieve? Once you know what you want to achieve and who your potential stakeholders may be, then you maybe want to select the project. Sometimes a lot of your external stakeholders and maybe even some of your internal stakeholders may not be on board. Your leadership can handle the internal stakeholders, but your external stakeholders, some of them just might not want to be along with a 3D model ride. So you're going to want to develop mitigating strategies or continue to produce some of the 2D set of plans for their use until they're as caught up as the construction industry, the design industry. Another thing that I think is important to do is engage people within your organization or consultants that do work for your organization that are interested, that they're passionate, that they're curious about 3D model and delivering. Folks that aren't interested in that stuff will not be of help to you to deliver your project, and they could in fact even be a hindrance. And when you're selecting a consultant partner, I believe it's important that you select someone that's both competent and someone that you just trust. Because there's going to be a lot of times, especially when you're sitting in these coordination meetings and workshops, where there's going to be a lot of conflicting interests and a lot of passionate people that want to do things one way or the other. So you're going to want a partner on board that can manage that successfully and make sure that everyone feels mostly comfortable about where we end up landing. From a project manager perspective, scope, schedule, budget, right, is what we focus on a lot. So if one of your goals is to not have a bunch of supplemental agreements, and your goal is to meet your original schedule without impacting your letting and your production commitments, which we have at FDOT, I'd recommend kind of more broadly scoping the job, because there's a lot of unknowns that you're not going to know up front that the consultant or your internal staff are going to have to deal with. So by using maybe like a limiting amount contract, or maybe also something, a mechanism has optional services built in, you can quickly account for those unknowns without holding up the project, processing an essay, and delaying your project by another 3 months. I'm very proud to say, I'm sure Gordon would say, that we delivered this project within the original scope, under budget, and 2 weeks ahead of schedule, which I will say is early. In terms of your schedule accordingly. At Turnpike, we normally do resurfacing projects in 12 to 14 months. I mean, we did do this job in 12 months, or I think about 13 months because we started early. But either way, I would strongly recommend maybe extending that to give yourselves a little bit more time. It was very strenuous for both the department and the consultant to get it done. But it is manageable. But again, by setting yourself up and giving yourselves time, the more external stakeholders you have, the more time you're going to need. In terms of delivering 3D models as a signed sealed contract document and reducing the set of plans, that requires a significant change in your workflow, both for the consultant and for the department, especially as it relates to things like plan specs and estimates, and as well as what we call ERC reviews, reviewing the phase submittals. Because again, our folks are proficient in the 2D realm, but not necessarily the 3D realm. So you want to be prepared for that. Start training folks, bring in external consultants in that can help, like I said, be the Uber driver for your 3D model. And this is the last thing I just want to point is that while 3D modeling, and not maybe not the 3D model, but 3D delivering as a signed sealed document is fairly new, I do promise you it is manageable and it can be done. It was very exciting, very rewarding for us, and I would recommend that if you're interested, please seek out your leadership and propose a pilot project or whatever your objectives are. And I think if you follow some of these steps, and as well as develop what works for you all, you will be successful. Gordon will talk to you a little bit about what some design considerations you'll have if you're the designer at EOR.
Some of the stuff's fairly obvious. Extra clicks. So hardware requirements, don't get chintzy. We noticed a significant difference about midstream. We upgraded from the machines we had to some more powerful machines. It reduced crashes because the processing speed was better, and it obviously processed the model faster. So big increase in efficiency. Limitations of the software up to now. I know Bentley's moving ahead with some things, but it does still crash quite frequently. Usability for end user. So I had some conversations down there with them. They're definitely moving on this, but the contractor and reviewers aren't proficient in getting into a 3D model and spinning around and finding out what your design is. So package it in a way that is more usable for those folks will be good. And then 3D drainage, we ran into some issues that need to be worked out as well. I covered those. Workflow, you're going to need a team of modelers, especially on a Turnpike project where they have an aggressive schedule to keep things moving. Design revisions, in some ways, especially towards the end of a project, you're not going to be able to run in there and make a quick change. Everything's in your model. That's your deliverable. There's no option to say, well, you know what? As long as the plans look good, we're fine. You have to go in there. You have to update the model. It has to be right. And sometimes that takes more time than it has traditionally. And then the QC process is obviously different. So we developed our own way of doing it. The other thing to note there is you need one of your top modelers set aside for the QC process. So once we start delivering everything in 3D, everybody's going to have a team of experienced and proficient modelers. And the last thing that helped make this very successful, and Jason already kind of hit on this, is having a progressive and innovative client. So DOT, especially Burns Group, but the Turnpike as well, we're both very aggressive and understanding of the pilot nature of this project, having the end goal in mind, having one vision. We all had that. Even though we went back and forth on some things along the way, we all had the same vision in mind of pushing the DOT and Turnpike further down the road towards this ultimate goal of 3D, and I guess completely 3D plans. So this is an important step towards that, and it was fun to be a part of.
So thank you everyone for joining us this morning. I hope you enjoy the rest of the HEAP conference. If you wish to contact us, Our contact information is on the screen here, as well as will be posted to the website. Like I said, I'm Jason Christopher, the HTB at the Turnpike. If you want a department project manager perspective, you can give me a call. Gordon Greene is both the consultant and the EOR for this project, so he'll probably give you a lot better information from a technical and delivery perspective from a consultant. With that, we probably have 1 minute. Can we take one question just real quick? Anyone have a really great question, the burning question?
In your state law for the signing and sealing, did it say that you can sign and seal electronic plans? And then if so, was your use of the specification to define plans considered enough legality, or how did you work through that?
So our state board does allow us to digitally sign and seal plans. Currently our board is working on a way to add, just like we did, to define plans to include the multi-dimensional model. Our state board hasn't enacted that yet, but we believe through our coordination and what we've done in this project, that we've met the intent of digitally signing and sealing in accordance with the Florida board requirements.
Thank you.
One more real quick, let's do it.
You said you had 32 models, so at the end of the day, when you created your final surface, did you submit 32 different models, or is it one giant figure? Because I think the state said at the end, or going forward, they just want one model, they want to put it all together in one complete surface. They didn't want 32 different surfaces at the end of the day.
Well, they got 32 on this one.
They got
That's the goal, right? We start out with the pilot, and maybe one day when like the I model comes into effect, just things like that, then maybe we can start doing that. But this is what we did on this pilot project, just to try to make it out the door within the constrained schedule we had.
Was your quality control for your vertical at the milling surface or at the paving surface? Did you use both paving and milling
Yes, sir.
in there, so you had it for both surfaces?
Yes.
And did you take into account the way a paver operates versus the way a milling machine operates in your crossfalls?
Yes.
Okay, so you built paving so that your crossfalls were working good, because we had a lot of trouble with the elevations if you didn't take into account the straight crossfalls for straight pieces of steel going across. So we had to develop milling plans, and we had to develop paving plans so that it matched if we're going to work with the elevation.
Yeah, well,
Did you run into
it
problems
goes
with the
back to what I was
safety way?
saying earlier. Obviously they're gonna mill to the surface, but we had to make sure that the surface we were modeling left it to where they could come back with uniform lifts and lifts that met the DOT specifications in terms of thickness, and not have any issues with having to go too deep or having or really too shallow would have been the issues. So we had to be diligent as the engineers on that side to make sure that we were in good shape.
And our construction and CEI partners helped. They helped us work through some of those issues and those similar concerns as well. And that's why we had to write the spec for the milling and the resurfacing. Both of them have them.
Okay, great, thanks.
All right, I'm gonna have
Thank
to cut you
everyone.
guys
Yeah,
off.
say
If
thank you,
there's any
everyone.
more questions, James and Gordon, they'll talk.